الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone, my name is Samia Ashraf. I am a Flutter developer working here in Dubai. I have 2+ years of experience working with the Flutter apps, and I'm very passionate about learning new things and teaching them to others. And I always like to learn about new topics. And the topic for today is Future Builder in Flutter, and we will also be looking at building a real-time weather app. So let us look at our agenda for today. So what is Future Builder? So we will discuss Future Builders in Flutter, what they are and why we need them. We will understand better with a syntax that explains the different parts of a Future Builder widget. So Future Builder is actually a widget, and we will discuss about the syntax. Then we will explore a simple example before we jump into building a weather app. And the weather app that we will be building is using the Open Weather Map API and also the Future Builder widget. Finally, we will see how widget gets updated when we call the API. And then we will have a small summary of whatever we discussed today. So let us look at what is Future Builder. Before explaining or before coming to the definition, let us consider a scenario. A scenario where you're building an app that shows the data from the API, meaning that the UI in your app depends on the data from the API. So it's like whatever you show in the UI is actually coming from the API. So when you make a call to the API, the widget runs into different states. Now, what are these states? These states can be like a loading state or a success state or an error state. And why do we need these states? These states are because API data is actually asynchronous. So, what does that mean? That means when you make an API call from your app, between the call to the API and actually getting the response from the API, there is a certain delay. And this delay, a lot of factors contribute to this delay. Like, for example, checking internet connection and making sure that the API endpoint is correct. So, in such situation, you need to notify your users that something is happening in the background, and that the widget is actually busy waiting for the API data. So this can actually be achieved using Future Builder, where you can display a loading, like a loader. So this is especially useful when your app is using API data, which is asynchronous. So now let us look at what is Future Builder definition. Future Builder is a widget which lets you determine the current state of a future and then choose what to show during that state. So this is the definition of Future Builder, and this is most commonly used for asynchronous operations where the widget depends on the result of a future. So Future Builder will then rebuild itself using the data from the API. So this is what Future Builder is in general. So Next, let us look at the future builder syntax. So on the right side, I have a future builder widget that has 4 parameters: key, future, initial data, and a builder. So what is a key? The key is the widget's key using which we can control or we can replace it with another widget. And next we have the initial data. So the initial data is the data that will be displayed before any call to API is made. This is the data which will load when the app runs initially. So the initial state of the widget. Next we have a future. So future here is an object which is going to control the builder function and decide which state it should render, like loading state or success state or error state. And this kind of function most of the time needs a trigger from the UI, either from the init state or from an on tap function. So, like for example, making the call to the UI, making the call to the API, initially you can place it inside the init function, but if you have a button click, then you can place it inside the on tap function. The next we have builder function. So builder function decides what should be displayed in the UI during different states of the future call. Now, let's say, like I said, before making the call to the API, it will be the initial state. After you make the call to the API, there will be a waiting state, the delay that we earlier discussed. And once the API call is successful, it will check for errors. So that is the success state. So connection state dot none. So one of the four, the future builder can run into one of the 4 states. The first one is connection state dot none. So connection state dot none is where there is no asynchronous method, that is no call to API is made, and the future here will be null because we have not interacted with the API call. The second state is connection state dot waiting. This means that the asynchronous method has been called and the future is currently busy fetching the data. Therefore, we should display a loader in the UI indicating that the future call is in progress fetching the data. So the third one, we can say connection state dot done. This is when the asynchronous method has been completed and the response is received. So the data from the API can either have errors or it can have null value. So that we will be checking using snapshot dot has error. So let's say you've made the call to the API and you have got the response data. Now this data can have errors. So that we will check using if snapshot dot has error. So first you will check if the API call was completed. Then we will check for the errors and then display the error widget if an error has occurred. Or else, if and we will also check if snapshot dot has data because sometimes the future returns with null value. So in that case, we need to display appropriate result. So let us now look at an example. So here I have on the left side, we have a future builder in action. So this future builder widget has a future parameter, which is a future album. Future album is actually a function where it fetches data from the API. So once it fetches the data, it will store it into a model, which will be then, which in UI we can access using the model called as album. So once the API call is complete, we will check for snapshot.hasData to check if there is data or null data. and then we will display the appropriate data in the UI. So when we make the call to the API, again, a loading indicator will be displayed in the UI. And once the API returns with the result, the loading indicator will go away, and then we will rebuild the widget using the snapshot.data.title, which we can see here in the screen. So the title will be displayed after the API call is successful. So now let us explore the weather app example. So here we will build an app that displays the weather data for the user's current location. Like for example, if you have opened this app will tell you the weather data for the current location from where you open the app. So this app, as soon as it opens, it calls the Open Weather Map API, and then it fetches the weather data and displays in the UI. So I have divided the steps so that we can discuss them in details. So the first step here is to get the API key by registering in the Open Weather Map API. The second step, we will see a simple UI that is built using FutureBuilder and stateful widgets. And then the third step, we will get the user's current city, because when you open the app and if it shows the weather data for your current location. So we will also see how the app will get your current city using the two packages, geolocator and geocoding package. Then we will see how the call to API is made using the HTTP request. And after the request is made and the API fetches the data, we will rebuild the UI to show the API data. And finally, we will search for weather data like uh, a city, any city's weather data, and then we will update the UI for that city. So the first step here is to get the API key. Register. So you will be using, I'm using here the Open Weather Map API. There are a lot of APIs which display the weather data. One of them is Open Weather Map API. And you need to register in order to get the API key, because without the API key, the API will not give you the weather data. It will just return with null value. So you will not have access to the API data without the API key. So this here is actually a process to, so let me just check if I can share my screen. Okay, so this is how you will register into the Open Weather Map API. And after the registration is successful, you will have access to the API key. So the link to which has been shared in the chat box. And like I said, you will not have access to the API data without the API key. So if you see the GIF file, once you complete the registration, so you will enter all of the details. And then you need to check the boxes. Once the account has been created, it will ask you for some questions. And then you will click on the name, the username, and click on My API Keys. You will have access to the API key. So that is how you can get the API key. And it is actually free, which you can then use it in your project. So the second step, after we get the API key, We will now build a simple UI with stateful widget and FutureBuilder widget. When working with future builders, it is always a good practice to call the API that returns the future object inside the init function. That means when you make a call to API that returns a future object, always call that API inside the init state, because if you place it inside the build method, then there are chances that during every widget rebuild, the API call will be called and it will call repeatedly, which will cause the app to slow down. So that is not a good practice. It's always a good practice to place it inside the init function. Now, for example, this app we will call the API twice. Once when we open the app and enter the screen, that time we will be calling the API from the init state. And the second time where I said we will search for a city's weather data, that time we will call it outside the init state, which we will discuss now. So next step is to get the user's current city. So for user's current city, I have used the geolocator package, which will return user's latitude and longitude, the current latitude and longitude. Now, this API will work with latitude and longitude values, but I want to search based on the city name. So I will do one extra step of using the geocoding package, and using the latitude and longitude and the geocoding package, I can extract the city name and then call the API using the city name. The next step is to make an HTTP request. Now, parameters, the API here will require two parameters, the city name and the API key. So once the call to API is made, the response object will be then converted into a weather model data type. So I will store the response from the API in weather model. Now the API response actually has a lot many parameters, but I will be only using three of them: the current temperature of the city, the name of the city, and the a message description about the city, like if the weather is cloudy or if it's rainy. So these are the three things that I will be rendering in the UI. So that's the reason in the weather model, I only have three parameters. You can add more or you can add less. Now the next step here is to rebuild the UI using the data from the API. So now that we've got the API keys, we have made the API call, and we have also fetched the data and converted the data into a weather model. So now the only step that is to render the weather model data into the UI so that the user can see the data. Now, during this whole process of calling the API, converting the data, and displaying into the UI, the app will run into two states: a waiting state and a success or an error state. So after the call to the API was made, the app actually ran into a waiting state. And when it ran into a waiting state, if you see here in the picture, I have displayed a circular progress indicator indicating that the future object is busy fetching the data. And it does not have any data because it is fetching the data from the API. So once the data is fetched, it will enter into a connection state dot done, which is this one here, the first one, when API is successful. And once the API is completed, we will check if it has errors. If it has errors, we will render the appropriate widget saying that some error occurred. And if it does not have any errors, we will check if it has any null values. And if it has null values, again an error widget will be displayed. And if it does not have null values, we will convert the API data into a weather model object. And once we have converted the snapshot data into weather model, then we will use it to render in the screen. So the first code here is where we are converting the snapshot data to weather model. And here, the second image here is where we are using that model data to render in the UI. So it makes it a lot more easier to access the snapshot data. So that's the reason we are converting it into weather model. Now, the second part to this weather app example is to search for a city using the API. Now, previously we searched for, we call the API using the user's current location, that is the city name. Now, let's say the user wants to check the weather data for a different city. So in that case, what we can do is we can enter the city name and call the function which returns the future result. So as per the future builder, you need to have a future object. So any changes that is made to this future object, according to that, the UI will render. So in this case, my future object is underscore my data. So my underscore my data is a future object of the type weather model. So it is of the type weather model because remember the API response will be converted into weather model. So that is the reason I have made it a future of type weather model that will store the data after the API call. So we will assign underscore my data to the future parameter of the future builder. This will ensure that whenever the my data changes, the UI will be rebuilt using the latest snapshot. So before we call the API with the different city name, the state of the application will have weather details for the user's current location. Once you call the API with the new city name, it will then start to show a loading indicator, a loader, saying that the future is now fetching new data from the API. New data because it is a new city name. So the future is busy, and that is why it will be showing a loader. Once the API call is successful, the future will be then populated with the weather model data, and then the UI will be rebuilt. So here is a simple zip file which will explain the working of the entire app. So once you open the app, it will show the users. So my current location here is Dubai. So it is showing Dubai with a message description and the temperature. And if I select a different city, so this is the initial state where it was loading. And since this is an emulator, it is showing the Mountain View location. So if I search for the location Dubai, it will enter the loading state and then it will show the weather details for mobile. So initially, when the Mountain View UI was shown, that was for the this emulator's current location, which was Mountain View. So after that, when I typed in the search text for Dubai, that is when I call the function again. So if you see here, when I set on tap, this is what I meant. So when I click on the on tap function, I will call the get data. I will call the API again, and I will assign the API response data to underscore my data. Underscore my data here is a future. So whenever when the moment I click on tap, the future will change to waiting state, because of which here we saw a loader. And after the API was fetched and converted to weather model, we then saw the weather locations for Dubai. So this is how it works. So it entered the loading state and then displayed the, so this is the connection state dot done. So the things that we covered in this session is we discussed about what are future builders and how we can use them in Flutter apps. And we also looked at what are the different states that the widget runs into when you make an API call, and how, after calling the API and getting the response, how you can update the UI with this response, and also how you can call the API again and render a new response. So I have a step-by-step tutorial written in Medium, where I have also shared a GitHub repo for the with the source code. So if you want to go through the source code, I will be sharing the links in the message box. So you can look at the tutorial and also refer to the code in the GitHub repo. So thank you everyone. I hope you got a basic idea of what future builders are, and you can read more from the Flutter docs. And yes, that's all. So if you have any questions, you can ask me. If you have any questions about future builders, or what are the different states, how does it change from one state to the other, you can ask any questions. All right, so thank you everyone for being a part of this session. I hope you've got at least a little bit insight on what future builders are. And yeah, thank you. The links have been shared in the comments. The links to also the Medium article as well as the GitHub links have been shared.